Okay, folks. Good morning, everybody. Are you able to see my screen?
Yes,
Yes,
sir.
sir. So last class we were discussing about now the position of the image in front of a concave mirror, right? So
Yes, sir.
we had seen different cases, right? Do you recall?
Yes,
Yes,
sir.
sir.
So can you just tell me quickly? Good morning, Akila.
Good morning, sir.
Good morning, ma. Friday, I think you missed the class, ma.
Yes, sir.
Okay, fine, fine. You're a biology student, are you?
Yes, sir.
Okay,
Yes.
fine. Okay, ma. So now, last class we had seen a few things. Could you recall, Rahil?
So, when the object is at infinity, the image forms at focus. If it's
Yes, yes. I'll just
beyond,
take you through that.
yes,
Okay. So now the object is at focus. I'm sorry. Object is at infinity. Image is formed at the
focus, it's real,
focus.
inverted, and very small.
Yes, ma. Yes. Then
The object is placed beyond the center of curvature. Then
yes.
the image is formed between focus and center of curvature.
Fantastic.
It's real, inverted, and small in size.
Very good. Very good. Then
Then, when the object is at center of curvature, the image is also at center of curvature.
and what
It's
can I
real,
say about size?
inverted, and equal.
Equal size. Very good.
After that, when the object is between center of focus and center of curvature and focus, then the image is beyond center of curvature, and it's real, inverted, and large in size.
Very good. Very good. Then we saw till here, right?
Then, yes, sir. When when the object is at focus, the image is at infinity. It's real, inverted, and very large in size.
Very good. Very good. Right. So these are the things we discussed. Now, one more in concave mirror. Let us discuss. If the object is going to be placed between principal focus and also the pole, are you able to see now?
Yes, sir.
Yes, sir.
In this case, what is going to happen is you can actually visualize this. You can also draw and see, like if this is your concave spherical mirror, this is the principal axis. This is your pole. This is the focus, let's say. And let's say the object is here. Now let's say if we draw for example, if we draw a line parallel to principal axis, after reflection it will pass through the focus. Okay, understood?
Yes, sir.
Okay, ma? Then another ray, we will draw another ray. Now let's say I draw a line, I draw a ray. If I draw a tangent here, the normal will be along the same line. Let's say this is the center of curvature. So it will get reflected along the same line. It will go like this, it will pass through the center of curvature. Are you able to visualize?
Yes, sir.
Should I explain this again?
Sir, can you please explain that, sir?
Okay, see here. So two rays I am drawing. So for getting an image, you need at least two reflected rays. All right. So this is the object. From the object, one ray is going parallel to the principal axis. If a ray is parallel to the principal axis, after reflection, it will definitely pass through the focus. Focus is not the image, but focus, through the focus it will pass. Understood?
Yes, sir.
Okay, this is one ray. Now another reflected ray we want. For that I can choose any one of them. I can actually choose a ray at the pole. Like this also I can choose. At the pole if you have, the same angle it will get reflected. So you got two reflected rays. Understood?
Yes, sir.
This is one possibility. Another possibility is with this also you can draw. Definitely these two rays will they meet ma? This violet ray and this yellow ray will they ever meet?
No, sir.
They won't meet, right? But then
Yes.
they both appear to come from some point. If I just extend this line, they both appear to come from a common point. So this point will become the image.
Yes.
Understood, guys?
Yes, sir.
Yes, sir.
So how is the nature of the image? Image, it is not real. It is what? Virtual. Why do I say it is virtual?
Because the actual rays aren't meeting.
Actually, the rays or the reflected rays are not meeting. They are appearing to come from some point. Are you able to listen to me?
Yes, sir.
Yes, sir.
Yes, sir.
Therefore, it is a virtual image. Is it erect or inverted?
It's erect, sir.
Erect because yeah. So you can see. Okay. Then what about its nature? Is it diminished or magnified?
It's magnified.
Exactly. So this is one way of getting the image. Another way is, I will tell you. Okay, instead of taking the violet ray like at pole, instead of that, I can choose one more point, which is the line joining the center of curvature to the point. You know what is this point? What is this point?
See, center of curvature.
Center of curvature, right? Now what you can do is, from center of curvature, through this object, you can draw one line. Are you able to see this?
Yes,
Yes,
sir.
sir.
Yes. Now, if a ray of light from the object, let's say this point is A, from A is going and hitting the mirror, then this is called normal incidence because if you draw a tangent here at this point, the normal will pass through center of curvature always. In a circle, if you see, radius and the tangent are perpendicular to each other, correct?
Yes, sir.
Yes. Rahil, are you there?
Yes, sir.
Yes, now okay. So what will happen is this ray after reflection will come back through the same path. Are you able to understand?
Yes, sir.
So these two rays will never meet, but they both will appear to come from some point. Understood?
Yes, sir.
So,
Now that point becomes the image. Suppose if this is AB, this will be A dash B dash. So same way you can understand. You know the image is going to be erect, magnified, correct? Erect, large in size, magnified, and virtual. And where is it found? Behind the mirror, correct?
Yes, sir.
Yes, that's all. So this is the next one. So only one case in the concave mirror where you're getting virtual image. In all other cases, you're getting real image, correct?
Yes, sir.
yes, sir.
Good. Is it clear?
Yes, sir.
Now let's look at convex spherical mirror. Now can you see the convex spherical mirror? This is the convex spherical mirror. In this, when the object is at infinity, what is happening? These are the reflected rays. Understood? Are you all seeing this?
Yes, sir.
Yes, ma'am. Rahul, are you looking at this screen?
Yes, sir.
Okay, okay, okay. So after reflection, they don't meet. These two rays are the reflected rays. Are they going to meet?
No, sir.
No,
But they
sir.
both appear to come from some point, and that point is called the image.
Image.
And that is it a virtual image or a real image?
Virtual image.
Virtual image.
Because
Virtual
the reflected rays are not meeting, but they appear to come from a point. Understood?
Yes, sir.
Therefore, it is virtual image and it is erect. Okay? And it is very small in size. Understood?
Yes, sir.
Okay. Then, wherever any other point you keep the object, any other point, then you can see how is the image formed. Image is always formed between what? Focus and pole. Wherever it is placed. Understood, ma?
Yes, sir.
And
Yes,
it is
sir.
always
Yes, sir.
virtual, it is always erect, and it is always small in size. Virtual image is always small in size, whether at f or any other point. Understood?
Yes, sir.
Okay,
Yes,
Yes,
sir.
sir.
fine.
So 1 minute, sir.
You want to take it down, or you want to
Yes.
understand? Okay, yeah. Please. Because once these are very clear to you, questions on this will be very simple to answer. Done, ma?
Yes,
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 sir.
sir.
Okay. Have you also noted down this?
Sir, one
Yes, sir.
second.
Yeah, yeah.
Done, sir.
Done, ma? Okay. Now let's look at the next concept. A mirror formula and magnification. Already we know what is the mirror formula.
1 by f is equal to
Yes,
1 by u plus 1 by v.
that's correct. So 1 by f, where f is the focal length, is equal to 1 by u plus 1 by v, correct? Then we learn about something called linear magnification. What do you mean by magnification?
So whether it's enlarged or
Exactly.
diminished.
So it is the ratio between the image size to object size, or image height to object height. Image height image height divided by the object height. And this, if you do the derivation, you will get it as minus v by u in case of mirror. Okay. You can see here, m is nothing but image height by object height. That will be equal to minus v by u. There are also other ways to write it in terms of f. It's very easy to get it. What is the formula we know? 1 by f is equal to,
By f is equal to 1 by u plus 1 by v.
correct. Now divide by minus v on both sides. Then what will happen? Understood?
Yes, sir.
Divide or multiply, sir? Multiplying here.
I'm sorry, multiplying. I'm sorry, ma. Multiply by minus v. So what will we get? Minus v by f is equal to, what is v minus v by u?
M.
Very good. It's nothing but m. And what is v by v? Minus v by minus v.
1.
Correct?
Yes, sir.
Yes, no? Okay. I'm sorry, this will be minus 1, correct? Because that minus v is only on the numerator, not on the denominator, correct? If you look at the formula, it is 1 by f plus is equal to 1 by u plus 1 by v. So if you multiply with minus v will be here, minus v will be here, and minus v will be here. Denominator will be v only, correct? So it will be minus 1. So what will you get? M is equal to, if you take this minus 1 this side, it will become what? 1 minus v by f.
It is V by F.
Yes. So if you take LCM, f minus v divided by f is magnification. One more formula. Can you see this?
Yes, sir.
Yes. I note it down. Similarly, you can find out the expression in terms of u. Have you noted down this?
Yes, sir.
Yes, sir.
Okay. We will now do for u. Again, the starting point is the mirror equation. What is the mirror formula?
1 by f is
By-
equals to 1 by u plus
1 by
1 by v.
plus 1 by
Right.
multiply
Now what
by
I
minus u.
now what we will do?
Multiply by minus u.
Minus U.
Correct. Multiply by minus u. So if I do that, what will I get?
1 by minus u.
Minus u by
minus-
f is equal to minus u by u plus minus u by v. Correct?
Yes, sir.
Yes. What is minus u by u?
Minus 1.
Minus 1.
So I will keep minus u by v this side. This minus 1, if I take it that side, it will become,
Plus 1.
so 1 minus u by f. So if I take LCM, I will get what?
F minus u by f is equal
That
to
is minus u by v. But we want,
m, so we have to take reciprocal.
exactly, we take reciprocal. Taking reciprocal, we get,
Minus v by u is equal to f by f minus u.
exactly. And that is nothing but magnification. So you're able to understand clearly?
Yes, sir.
So what is magnification? F by f minus u. Clear?
Yes, sir.
So there are three formula. M is equal to minus V by U, or F by F minus U, or F minus V by F. Once you take it down, let me know. Then we'll move on to the questions.
Done, sir.
Done, Rahil? Okay. What about
Done, sir.
Done, sir.
Done, no? Okay, fine. Okay. We should use sign convention while solving the problems. You will understand. Okay. Now let's answer the questions one by one. Question number 12. Just observe and answer. A diminished virtual image can be formed only in
Convex mirror.
convex mirror. Very good, very good. Because we already saw in concave mirror, only in one case you get virtual image, correct?
Yes, sir.
That is when you place the object between
A focus and principal
pole.
axis.
Pole.
Pole.
Okay?
Focus
And
and pole.
that image is virtual, but it is enlarged, correct?
Yes, sir.
Diminished image, virtual image, always you will get it with
Convex mirror.
convex mirror. That's the correct answer. Understood?
Yes, sir.
13th one. Okay. A person sees his virtual image by holding a mirror very close to his face. When he moves the mirror away from his face, the image becomes inverted. What kind of mirror is he using?
Concave mirror.
Concave mirror, exactly. Because you can see in concave mirror, you will get a virtual image when the object is between what?
Focus and pole.
Focus and pole, very little distance, right? Then if you move it further, that means object is placed at the focus and beyond. So when you do that, immediately the image will be
Inverted.
inverted. Exactly. All right. Okay. Good. So the mirror used is concave mirror. Clear?
Yes, sir.
Yes. Next.
Yes, sir.
Relationship between linear 14th one. The relationship between magnification, object distance u, and focal length f is
Option B.
yes. So what is option B? F by f minus u. Already we derived it. Correct?
Yes, sir.
Okay. Now, an object is placed 40 centimeter from a concave mirror of focal length 20 centimeter. What can you say about the image formed?
Sir, it's real, inverted, and same in size, sir.
Excellent, Rahil. So there is, in fact, the same sum you can do it using formula 1 by f is equal to 1 by u plus 1 by v. You can substitute us minus 40 and fs minus 20, and then you can find v. But that will take nearly 5 minutes. But Rahil answered this within a few seconds. How did you do, Rahil?
Sir, radius of curvature is always similar to or equal to twice focal length, sir. So since it's given 20 centimeters and 40 centimeters, means the object is placed at center of curvature. So when the object is placed at center of curvature, the image is real, inverted, and same in size.
Very good, excellent. So let me take you back to the, very good, Rahil, for everybody's understanding. I'm just going to take you to that part. Okay, now you can see this place, everybody. Where is the image formed? If you see, where is object placed?
At center of curvature.
What is this distance from the pole? It's called radius of curvature, correct?
Yes, sir.
Yes, sir.
And r is equal to,
2f.
do you remember? And what is this distance? Focal length,
Focal
Focal
length.
length.
correct? No? So your focal length is f. Then where is the center of curvature at?
2f.
12.
Correct? That's what is given in the question. So focal length is given as 20 centimeter. and the object is placed at 40 centimeter. 40 centimeter means how much? 2f, correct?
Yes.
Yes, sir.
And 2f is nothing but it refers to C. Understood? When the object is
Yes.
placed at C, then the image will be formed, which will be what? Real, inverted, and what?
Same in size.
Same.
Same in
That's all
size.
right. So immediately you can spot the answer. So the right answer for this question is. So what is the right answer for 15th question?
Option A, real inverter and same in size.
Suppose you forgot this. Suppose you did not remember this. Then how do you do the sum?
We use the
Use the
mirror formula.
Mirror
multiplication
formula.
formula.
Exactly. You can use the mirror formula and get the answer anyways. For example, 1 by f is equal to, come on, 1 by u plus 1 by v.
1 by V.
But you have to use sign convention. So this is the concave mirror. F is here. You are measuring from the pole. You are going in towards left or towards right for measurement?
Towards
Towards left.
left.
Towards left.
It's
Always start the
minus.
measurement from pole. So minus. So wherever. So F, how much is the answer? It's 20 centimeter. So you must substitute minus 20. Understood?
Yes, sir.
Then 1 by u. Where is the object? Object is at C.
40.
So here also you are starting from pole going to C. So
Minus
negative or
40.
positive?
Minus
Minus
40.
40. Minus 40. Plus 1 by V. We don't know what 1 by V is. So 1 by V, we'll keep it as it is. We'll take this minus 1 by 40 to the other side. So it will become 1 by 40.
Plus 40 minus 1 by 20.
So if you take LCM, it will be 40. 1 minus 2. So what is the answer?
Minus 1 by 40.
Minus 1 by
Minus 1
40.
by 40. Correct. So image is also formed at a distance of 40 in the left side. Correct. That's why you are getting negative sign. Understood?
Yes, sir.
Yes, sir.
Right. Understood. So you can immediately say it is formed exactly at the center of curvature only. And at the center of curvature, at least you must remember, or if you want, you can do magnification also if you want. What is magnification?
Minus V by U.
Yeah. What is V? Minus 40. What is U?
Minus
Minus 40.
Minus 40.
Understood? No? So negative sign 1 cancels. So you get minus 1. Correct? From
yes,
this
sir.
information, you can clearly see. Right? You can clearly see negative sign indicates it is
Inverted.
Positive.
inverted. 1 indicates it is
Same in size.
same in size. So it's inverted, it is same in size. Only one option is matching, correct?
Yes, sir.
And in a concave mirror, unless you place it between principal focus and the pole, you won't get a virtual image. You'll always get what image?
Real image.
Real image.
Yes. So, in case if you forget about this, then you can, this is how you can solve the sum. But the best way to answer is just by observing where you are placing the object and where the image will be found. From those, if those diagrams are clear in your mind, then you can answer this question very easily.
Yes, sir.
Yes, ma'am. Good. You noted down, Akila, or shall I wait for a minute?
Done, sir.
Done, ma'am. Okay, great. Okay. Okay, radius of curvature of a concave mirror is 40 centimeter. The size of the image is twice as that of the object. Then the object distance must be. Either you can use 1 by f is equal to 1 by u plus 1 by v, or you can also use logic to answer this question.
So is it 30 centimeters, sir?
Yeah, 30 centimeter will be correct. Okay. So can you explain, Rahil? How did you tell
So,
30?
so because when the object is placed between center of curvature and focus,
Yeah.
it's the image size is large in size, sir. But if it's placed in focus, it'll be at infinity.
Yeah, it will
So
be infinity. It will be infinity. Therefore, the magnification will be very, very
very, very, very large.
small.
So
Yeah,
it
very
should
large, very
be,
large.
yeah. So it should be, the object should be placed between center of curvature and focus.
Focus is at
So
20 centimeter. Center of curvature is at 40 centimeters. So answer
40
must be
centimeters,
between 20 and 40.
which is 30, sir.
Very good, no, very good. That's the way you should answer the question, right? Or else, if you did not know this, if you're not able to think like this, then always you can use the mirror formula to get the answer. Okay, size of the image is twice the size of the object. So m is equal to minus v by u. Twice means it can be either minus 2 or plus 2, correct?
Yes, sir.
Yes, sir.
But point is, it cannot be plus 2 because for getting plus 2 means you are getting erect image.
Yes, sir.
For that you should, that means erect virtual image. For that, you must have the object between focus and the pole, which means the answer must be less than 20. Do you have any option less than 20?
No,
No,
sir.
sir.
No,
Therefore,
sir.
therefore it is not plus 2. It has to be only,
-2.
yes,
Minus
that
2.
much you can understand. Then radius of curvature is what? 40 centimeter. I'm taking minus 40. I hope you understand.
Yes, sir.
Yes,
Yes. So what will be the focal length?
minus
-20.
20.
Correct. Now what you can do is you can use mirror formula. 1 by f is equal to
1 by u plus 1 by v.
1 by u plus 1 by v. Now we want to find out v only. So it is 1 by minus 20 is equal to, either you can use this formula or directly you can use what? What formula we have seen? If you know u, then directly you can use what?
F
F
by
by
f
f
minus u.
minus u.
F
Yeah,
by
that can be directly used. Okay. So magnification is equal to f by f minus u, directly you can use. Or if you want to find v, then you can use what? F minus
F
v by,
minus v by f.
yes. So we'll use that formula. Because we want to find v directly. So magnification is minus 2, which is equal to, what is f?
-20.
Exactly. Anything we are missing, ma? Or we just check? Are we getting minus 20?
Sir, you will get us 30, sir, if you use that formula.
You, right? You only we want, correct?
Yes, sir.
What is asked in the question? Object distance, I'm sorry, ma. So you use the other formula only. M is equal to f by
F minus
f
u.
minus u. So minus 2 is equal to minus 20 by minus 20 minus u. Yeah, now you're correct. So if you multiply minus 40 plus 2u is equal to minus 20.
It's minus 20 is down, sir. So on
Minus
top will be
20,
plus
minus
40.
20, minus 20. Yes, so it will be plus 40. So 2u is equal to minus 60 So u is equal to minus 30 centimeter. Magnitude wise, it will be 30 centimeter. Correct. But best thing is to analyze like what he did, right? You understand that radius of curvature is 40, which means focal length is 20. Size of the image is twice as that of the object, which means if it is real image, then it is going to be between focus and center of curvature. So focus is at 20 centimeter, center of curvature is 40 centimeter. Answer must be between those two. So 30 is correct. Are you all clear, guys?
Yes, sir.
Yes,
Yes,
sir.
sir.
Good, good, excellent. Now let's go to the next question. Question number 17. Now tell me, if an object is placed 10 centimeter in front of a concave mirror of focal length 20 centimeter, what will be the image? I think you're muted.
So it's it'll be dim in front of concave mirror. So enlarged, upright, and virtual.
That's all. That's all. Immediately, right? Which is the last thing which we discussed, right? In case of concave mirror today.
So when it's placed between focus and pole,
Yes.
the object will be virtual,
Yes.
uh,
Image will
erect,
be
and large in size.
perfect. Perfect. Right? So, which is nothing but this one which we had seen. Understood, guys? When the object is placed between focus and pole, then you get a virtual image, erect, and it is large in size. Understood?
Yes, sir.
How do you know that you are placing it between pole and focus? Because it's given focal length is 20 centimeter, object distance is 10 centimeter, which means it is between pole and focus. Understood?
Yes, sir.
That's all. Again, same sum you can get it using what?
1 by f is equal to
Yes,
1
1 by f is equal to 1 by u plus 1 by v. You will get v as positive answer. When v is positive, it means on the other side of the mirror, therefore it is virtual. And magnification, if you see, it will be a large value. And magnification will also be plus value, so upright. So enlarge, upright, and virtual. But with logic, you can answer it within a few seconds. Clear, guys?
Yes, sir.
Yes, sir.
Yes. Next one. Concave mirror of focal length f is immersed in water of refractive index 4 by 3. Focal length of the mirror in water will be. Any idea?
So should we use 1 by f is equal to 1 by f1 plus 1 by f2?
No, nothing. No. That is only if you have combination, right?
Yes, sir.
Right. So here, what they are asking is in air, the focal length of the mirror is how much?
F. So
F. Suppose if you immerse the whole thing in water, whose refractive index is 4 by 3, then will there be any change in the focus? Okay. So answer is no change will be there. So answer is F only. If in air it is focal length is F, then in water also it will be
F.
f
F.
because
That
the
is
size
only in
is
case of mirror. In case of spherical refracting surface, if refraction is happening, then focal length of the spherical surface will change.
yes, sir.
Okay, yeah. In case of mirror, only reflection is happening. Therefore, focal length of the mirror will be same. Okay, guys. Shall we go to the next one?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay. Now tell me, if an image of magnification 1 has to be found by a concave mirror of focal length f, then where I should place the object? Simple question.
At 2f.
That's all, at 2f. Once again, the diagram must come to your mind, okay? At 2f, that is nothing but center of curvature. If you place the object, image will be inverted. And how much size?
Same.
Same
Same
size,
size.
right? Image will also be formed at 2f. So the right answer is third option. Are you clear?
Yes, sir.
Next, a concave mirror forms an erect image twice the size of the object. Erect image, okay? Concave mirror. Then what must be the object distance? This also you can answer within a minute, within a few seconds.
F/2.
F by 2 is
Right.
correct. Because a concave mirror is forming erect image means there is only one option. When it will happen?
It's between focus and
It
pole.
will let this.
Yes, when the object is placed between focus and pole. That means your object distance must be less than f. All
Yes.
the other options are more than f. Only the first option is less than f. Therefore, the right answer is
F by 2.
yes. Or else you can also do what?
Use the
1
mirror.
by F.
Yes, you can use the mirror formula and magnification formula to get the answer. Okay.
Yes.
Are you clear, guys? Do you understand once you spend a little time in understanding the image is formed by concave and convex? These questions are very simple to answer, correct?
Yes, sir.
Yes, sir.
Yes. Sir.
Good, good. Okay, next question. Okay, this is based on the basics. Sometimes in PU you may be asked to derive R is equal to 2F. In that derivation, you will get this diagram. Okay. Now, what is asked in this question? AK, AB, and BK represent incident and reflected rays. Clear?
Yes, sir.
Yes, you can see
Yes.
that. I've already told you. If a ray is coming parallel to principal axis, it's a convex mirror, right?
Yes. Yes, sir.
So you can see the incident rays coming parallel to principal axis. That means after reflection, it will be going like this. And it will appear to come from which point? Focus, correct?
Yes, sir.
Yes. And we know that normal whenever you draw, that normal will always pass through what? Center of curvature. Because,
Center of curvature.
yes, because tangent at the point and the normal are perpendicular to each other at the point, correct?
Yes, sir.
Okay, now we are asked a few questions. BCF is how much? The theta is how much?
35 degrees.
35 degrees. Then what will be BFP? That is asked, this angle. Correct, no?
Yes, sir.
Now, very simple. I'll just do the derivation. So with this, you can also do the derivation, right? For your exam. So if you are asked to prove R is equal to 2F, then this is exactly the same derivation you have to do. So drop a perpendicular. Let it meet at, okay, M is already used. So let's do X. So BX is the perpendicular. So you're having two triangles now. What are the two triangles? Triangle BFX. What is this? Triangle
BXF.
BFX, right? Okay. And also one more triangle is there. What is the other triangle? BCX,
BC.
which is this triangle. Are you able to understand? Clear?
Yes, sir.
Okay. So we have triangle BFX and triangle BCX. Okay. Now if you see, Can you tell me what is this angle? Can you tell me? This angle is known. So can you tell me this angle?
35.
35.
Yes, this will also be theta. Understood or not?
Yes, sir.
Yes,
Why
sir.
this will be theta? Because these are two parallel lines cut by a transversal. So corresponding angles will be
Same.
same. So this is theta, right? But is it not the angle of incidence?
So angle NBK is also same.
Yeah, this angle will also be theta. Understood or not? Because angle of reflection.
Yes, sir.
Yes. Then look at this now. These two are parallel lines, correct?
Yes, sir.
Cut by a transversal. So what is this total angle?
180.
No, no, not only this angle, which I am drawing with green color.
Oh, theta plus theta, 35 plus 35.
Yeah, 2 theta, correct?
2 theta.
Then what do you
Yes, sir.
expect this angle to be?
2 theta.
2 theta, exactly. That is what is asked. So answer is how much?
70.
70.
70 is correct. Understood?
Yes, sir.
Based on this only, we will get that if you do similarity of two triangles, then you will be able to understand. This f is equal to 2r. You will be able, sorry, r is equal to 2f. Like that you can prove very easily. Because in triangle BFX, what is tan 2 theta? You prove that this is 2 theta, correct?
Yes, sir.
So tan 2 theta will be opposite by adjacent, correct?
Yes, sir.
Bx by xf. And what will be tan theta in this triangle? Bx by xc. Tan 2 theta is approximately equal to 2 theta because theta is very small. So it will be bx by xf is nothing but focal length, correct? Approximately.
Yes, sir. So can't we just do directly, sir?
How directly, ma?
Like 2
No, no,
theta
this,
will be.
no, no, this sum is over.
Yes, sir.
I am teaching you how r is equal to 2f.
Yes.
Suppose if you are asked in your PU exam, okay? Then this is theta is equal to bx by xc will be nothing but r. Tan theta is approximately equal to theta, bx by xc is nothing but r, correct?
Yes, sir.
Yes, sir.
Because x and p are very close. So xc is same as pc. Are you understanding?
Yes, sir.
Yes. Now, in place of theta, what I can substitute?
bx by r.
Bx by r. And on the right hand side, what is there?
bx by
BX by F.
X by F.
What will cancel? Bx and bx will cancel.
BX and
Cross multiply, what do you get?
2R is equal to F.
2F.
R is equal to 2f. Or
R.
f is equal to r by 2.
2r by 2.
Understood, ma?
Yes, sir.
So this
Yes,
is what is
Yes,
that
sir.
derivation. Of course, our sum, we don't require any of these. We just need that getting till 2 theta. That is enough.
Yes, sir.
Yes. So if you want to note it down and let me know. Then we can go to the next question. I'll be back in a moment, guys.
Yeah. Yes, sir. Done, sir.
You guys are done?
Yes, sir.
Akila?
Done, sir.
Done? Okay. Okay. Now we'll go into total internal reflection. I want you to just go through the concept for 5 minutes. Is it visible?
Yes, sir.
Yes, sir.
Just go through it, ma. Go through it for 2-3 minutes. Okay, now next we are going to discuss what we call as total internal reflection. Okay, although we call it as reflection, it is based on the concept of refraction. Okay,
Yes, sir.
so let's first understand basic refraction concept. Now let's look at refraction at a plane surface. Let's say this is a plane surface separating two media. Let's say this is medium 1, this is medium 2. Now let us say a ray of light is coming and getting incident at a point on the surface. Let's draw a normal. Okay, the angle between the incident ray and the normal is called angle of incidence.
Angle of incidence.
Yes, ma'am. Now, if the medium of separation was not there, the ray would have gone like this, correct?
Yes, sir.
But now, this ray is going to bend either towards the normal or away from the normal, depending on the refractive index of the two medium.
Yes, sir.
Suppose let us say refractive index of the first medium is mu1 and refractive index of the second medium is mu2. Let's say mu1 is air and let us say the medium 2 is glass. It is moving from which medium to which medium?
Rarer to denser.
Rarer to
And it is going from rarer to denser. So this is a rarer medium. This is a denser medium. When the ray of light is going from rarer medium to denser medium, the refracted ray will bend
Towards the normal.
towards the normal, exactly. So the undeviated ray would have gone like this. If it is bending away from the normal means it will go like this. Towards the normal means it will be coming like this. Understood?
Yes, sir.
So in this case it's going to bend towards the normal. Why is it bending towards the normal? Because the ray is going from
rarer to
Rarer to
denser.
denser.
exactly. So this will be the angle between the normal and the refracted ray. So this is your incident ray. And this is our
Refracted.
refracted ray, and this angle is called angle of refraction. Clear?
Refraction.
Then we have
Yes,
something called Snell's law, which is governing refraction. It's also called law of refraction.
Sin R by sin R is equal to constant.
Yes, ma'am. So the refractive index, the ray is going from first medium to second medium, mu1 to 2, correct?
Yes, sir.
It
Yes.
should be given by mu2 divided by mu1,
One.
and that will be equal to sine of the angle of incidence I
By sin R.
divided by sine of the angle of refraction. Is it clear?
Yes, sir.
Yes.
Yes.
Now, let us see what will happen if the ray goes from denser to rarer medium. Is it clear? Have you noted down?
Yes, sir.
Yes, sir.
Akila, you noting down now?
Yes, sir.
Yeah, once you are completed, you completed, let me know. So in this case, mu2 is greater than mu1, correct? Denser medium will have higher refractive index.
Done, sir.
Done, ma? Okay. Now in terms of velocities, can you tell me whether the velocity of light will be different in both the mediums or same?
It will be different.
Will be
Different, right? In a rarer medium, light will travel faster.
faster.
So if you say velocities as v1 and v2, mu1 is less than mu2, but v1 will be. What about velocity in the first medium and velocity in the second medium? Tell me. Yes, Alvin. Can you hear me? Rahil, can you hear me?
Yes, sir.
Yeah, tell me, Ma. So, denser medium means more diffractive index. Mu2 will be greater than mu1. I'm asking you, what will be the velocities?
In denser medium, it will be slower, sir. In rarer
Yes.
medium, it will be
So,
faster.
that means v2 will be.
Greater than V1.
No, less than v1. V2 is the velocity in the denser medium.
Denser medium. Then V2 is lesser than V1.
Understood or not?
Yes, sir.
Yeah. And what about wavelength? You know, you've heard about wavelength of light, right?
Yes, sir.
Wavelength also will be similar to velocity. So wavelength in the
It will be
denser medium will be less
than
than wavelength in the rarer medium.
rarer medium.
Understood. Frequency will remain same because if you consider light as a wave, it will have frequency, time period, wavelength, correct?
Amplitude.
Yes.
Yes. So frequency will be remaining the same. Velocity and wavelength only will change. Have you guys noted down?
Yes, sir.
Yes, sir.
Okay. Now let's move on to what happens when the ray of light is traveling from denser to rarer medium.
Right.
Right? Let's say this is the denser medium. Let's say this is the rarer medium. Let's say the refractive index here is mu1 and the refractive index here is mu2. And mu2 is greater than mu1. Now, let us take incident light. Incident ray of light is coming like this. Say this is the normal. Now, if the ray was, there was no separation of the medium, ray would have gone like this, correct?
Yes, sir.
Yes. But now what is going to happen? It's moving from what medium to what medium?
Denser to rarer.
Denser to rarer means the refracted ray will bend towards the normal or away from the normal?
Away from the normal.
Away from the normal.
Away from the normal.
Towards the normal means like this. Away from the normal means like this. Understood?
Yes, sir.
Yes, sir.
So which way it's going to move?
Away from the normal.
Away from the normal like this. Understood?
Yes, sir.
Yes,
Very
sir.
good. Very good. Right? Okay. Now if you see, this is your angle of incidence and this will be angle of refraction. Correct?
Fraction.
Yes.
Yes, sir.
Okay. If I further increase the angle of incidence, for example, let us say it was here, but now I'm going to increase it further like this. If I'm going to make. Let's say this is the incident ray. Now have I increased the angle of incidence?
Yes, sir.
Yes. If there was no separation of mediums, it would have gone like this, correct?
Yes, sir.
Now what will happen? It will bend.
Away from the normal.
Away from the
Yeah, so
normal.
it's going to be bending like this. Understood?
Yes, sir.
Yes, sir.
Okay. Now I'm going to increase the incident ray still further. Angle of incidence still further. Then now what is going to happen?
It will bend
Angle
It will
of,
increase again.
angle of refraction will still increase. Are you able to understand?
Yes, sir.
Yes, sir.
Now what I'm going to do is, I'm going to increase little further. Then what is going to happen? It is going to bend so much that refracted ray will be grazing the surface. Are you able to visualize this?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah. So this angle of incidence is called critical angle. You can call it as angle C or IC. What is IC?
Critical angle.
Critical angle.
Critical angle of incidence for which the refracted ray grazes the surface.
It's 90 degrees.
90 degrees. The angle of refraction at this stage is 90 degrees. Understood?
Yes, sir.
Yes, sir.
Okay. Now let me write the expression for this. You know the ray of light is traveling from what to what?
Denser to rarer.
Denser to
Denser to
rarer,
rarer.
which means mu2 to,
mu1.
that means 2 to 1, which means mu1 divided by mu2, correct? It's
Yes,
not
sir.
1 to 2, it is 2 to 1, understood? Okay, that will be equal to sin I by sin R. And what is that angle of incidence? IC, which is what?
Critical angle.
Critical
Critical
angle incidence.
angle IC is the critical angle of incidence. At the critical angle of incidence, what is happening?
Refracted angle is 90 degrees.
Yeah, refracted ray grazes the surface, right?
Yes, sir.
Separating the through two media. And your angle of refraction is
90 degrees.
90 degree.
so instead of sin R, I can write what?
Sin 90.
Sin 90. And let us say refractive index of the denser medium is mu. And rarer medium, let it be air. In air, the refractive index is taken to be 1. So mu1 will be nothing but what?
1
And mu2 will be
mu.
mu.
mu, and that is equal to sin IC divided by, what is sin 90?
1
Therefore 1 by mu is equal to,
Sin IC.
or I
Sin
can
IC.
write it as, if you take reciprocal, mu will be equal to,
1 by sin.
1 by sin IC.
this is the relationship between refractive index and the critical angle. Are you clear?
Yes, sir.
Now suppose if I increase the angle of incidence little more than this, I is greater than IC, then what is going to happen?
It's going to
If-
come back to the
It
same.
is going to come back into the same medium. It is actually refraction only, but because of this scenario, it is coming back into the medium, which is looking like reflection. If the ray comes back into the same medium, we call it as reflection or refraction.
Reflection.
Reflection.
That's why you say it is called total internal reflection. Why do you say total internal reflection? Because anyways, some amount of energy will be anyways reflected back. But now the refracted ray also is coming back into the medium. Therefore, completely the energy is transmitted back into the medium. Therefore, it is called total
Internal reflection.
Internal
reflection. What is the condition for total internal reflection to happen?
angle of incidence should be greater than critical angle of incidence.
Yes, angle of incidence must be greater than the critical angle of incidence, and first and foremost condition is the ray of light must travel from denser to rarer medium. This will never happen if ray of light is traveling from what? If the ray of light is traveling from rarer to denser, it will never happen because
Yes, sir.
the refracted ray will bend towards the normal, not away from the normal. Correct. Am I audible, Rahil?
Yes, sir.
Yes. Could you repeat the conditions?
So it should travel from denser to rarer, because if it travels from rarer to denser, it will go towards the normal.
Yeah.
So first is it should be denser to rarer, and the second is the angle of instance should be greater than critical angle of incidence.
Exactly. And what is the relationship between refractive index of the denser medium and critical angle?
So for critical angle, sir,
Critical angle and refractive index of denser medium. Mu and IC, what is the relationship?
mu and IC. So 1 by mu is equal to sin IC, or mu is equal to 1 by sin IC.
Or you can write it as mu is equal to cosecant C also, cosecant IC also, because 1 by sin is cosecant.
Yes, sir.
Yes. Have you noted down this?
Yes, sir.
Yes, sir.
1 minute, sir.
Yeah, I'll give you a minute. Please take it down.
Yes, sir. Done.
Have you all noted down?
Yes, sir.
Yes, sir.
Okay, we'll go to the next. We'll go to some concepts and questions here. Okay, then of course you will maybe compare between violet to red. So I'll just give you an idea about that. White light is composed of how many colors?
7.
7 colors. Okay. So now if I write these colors right in order, it will be WebGR, right?
Yes.
Okay. Violet, indigo, blue, green, yellow, orange, and red. Correct.
Yes, sir.
Yes, sir.
Now, what are the quantities which are increasing from violet to red, and what are the quantities which are decreasing from violet to red? Let's see. Okay, because velocity of light, wavelength of light, refractive index of light, deviation, all these things are going to be different for different colors. Okay,
Yes, sir.
any idea for which color deviation will be maximum?
So red, sir.
Red.
Violet deviation is maximum.
Mm,
Okay, so deviation is maximum. One second. Deviation is maximum for violet color. Okay,
Violet.
why?
Yes.
Because velocity is least for violet color.
Violet.
So here velocity is greatest for which color?
Red, sir.
Red. Velocity is greatest for red color because at high velocities deviation will be less.
Yes, sir.
Deviation is least for red color, greatest for violet color. Understood?
Yes, sir.
What about refractive index? Greatest for violet, least for red. Velocity and refractive index are inversely proportional. More the refractive index, less will be the velocity.
Yes, sir.
Yes, okay. Velocity and wavelengths are similar. So, wavelength of red is more or violet is more?
Red, sir.
Yeah, wavelength for yellow is more or blue is more?
Yellow, sir.
Oh, sir.
Very good, very good. Velocity for orange is more or velocity for indigo is more?
Orange.
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 Yes, ma'am, yes, very good. Refractive index for blue is more or refractive index for green is more?
Blue, sir.
Blue, sir.
Blue.
Blue is more, very good. Deviation for indigo is more or deviation for yellow is more?
Indigo.
Indigo.
So just by looking at this, you can answer all these questions. Okay. What about critical angle? Why? Because mu is inversely proportional to sin IC, correct?
Yes, sir.
Critical
Yes, sir.
angle and refractive index are inversely proportional. Critical angle
Yes.
is maximum for which color?
Red.
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 Yes. Refractive index is maximum for
Red.
Red.
refractive index maximum.
Violet, sir.
Refractive. Violet.
Correct. Understood? Okay. So these
Yes.
this can give you this, you can note it down. This will be very helpful in solving the sums.
Done, sir.
Done, ma?
Yes, sir.
Akila, done?
Done, sir.
Okay. Now let's move on. Okay, and also you can understand temperature. With temperature rise, refractive index of the material decreases, therefore critical angle increases. If you increase the temperature, material will become less denser. That means refractive index will decrease. Because of that, refractive index and critical angle are inversely proportional. So if you increase the temperature, refractive index will decrease, critical angle will increase. Is my voice clear?
Yes, sir.
Yes,
Okay.
sir.
So,
Let's now look at the questions. Okay. Okay. Now can you read the question? If the temperature of the medium increases, then what happens to critical angle?
Increases, sir.
Critical angle
increases.
also increases.
Increases.
Yes, good. Then, what about the next one? Ratio of the wavelengths of light passing from one medium to another is 4:5. What is the ratio of the speeds in the two media?
4 is to 5.
4:5. I told you about the wavelength. Wavelength and velocities are directly proportional, correct?
Yes,
Yes,
sir.
sir.
Yes, sir.
Next question, make a small change. First part is the same. Ratio of wavelength of light passing from one medium to another is 4:5. Then the ratio of the refractive indices of light in two media. Can you hear me, guys?
Yes, sir.
Yes,
Yes, sir.
sir.
24th question, there is a small change. What is the change?
Not speed of light, but refractive
Then
index of
the
light.
refractive index of
Yes,
So 5 is to 4.
5:4 is correct. Because refractive index and wavelength are
Inversely proportional.
inversely
inversely
proportional.
proportional. Correct. Okay, let's go back. Okay, 25th one. When light travels from one medium to another, having a different refractive index, then which of the following will change?
Wavelength and velocity.
Wavelength and velocity is correct. I
Increases.
told you frequency will remain
Constant.
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 Yes, because energy will be constant. E is equal to h nu. Okay, next question.
Violet, sir.
Yeah, critical angle will be minimum for they have asked. Critical angle will be minimum when it will be
For violet, sir.
For violet.
violet. Yes, violet for critical angle is maximum for red.
Red.
Yes, very violet is correct. Yes. Then next one, critical angle for a medium is 45 degrees. What is its refractive index? What is the relationship between refractive index of the denser medium and the critical angle?
So it's root 2, sir.
Yes.
Root 2 is correct, right? Because 1 by sine. What is the angle?
45.
5.
Five.
And what is sine 45?
1 by root 2.
1 by
So
root 2.
refractive index becomes root 2.
Root 2.
Able to understand?
Yes, sir.
Yes, sir.
Noted now?
Yes, sir.
Done,
Yes, sir.
sir.
Okay, next. Same, based on the same concept, you have two more questions. Can you answer these two questions? Refractive index is given, critical angle is asked. So what is sin IC? Yes, ma, tell me.
So 30.
30 degrees is correct because sin IC is equal to 1 by mu. Mu is how much?
2.
So for what angle sin theta is 1 by 2?
Sin 30.
Sine 30.
That's all. Next question also same, only mu is different.
60, sir.
Yes, sin IC is equal to
60.
1 by mu. 1 by mu means 1 by 2 by root 3. So this will become root 3 by 2. So for what angle sin theta is
Sin
root 3 by 2?
Sin 60.
Sin 60. Clear for you?
Yes, sir.
Yes, sir.
Yes, good. Now let's go to the next question. Okay, I will send the worksheet to you so that you can have the questions also, you can use it for revision also.
Yes, sir.
Yes,
Yes.
we'll go to the next question. Wavelength of light in two liquids is given as 3500 and 7000 angstrom. Then what will be the critical angle? Of x with respect to y?
Sir, 30, sir.
30 is correct. Can you explain how, Rahil?
Sir, because it's like inversely proportional to mu, sir. So I did the proportionality. So with that, I did sin I. So it'll be
Yes.
2.
Yes,
Mu
ma'am.
will be 2 and
That's correct. Okay.
sin IC will be 1 by 2.
Yes, right. So let me, that's correct. Okay, if you want to do it in details here, medium X has lower value of wavelength, Y has higher value of
Higher.
wavelength. So which is rarer medium, which is denser medium? Lesser the wavelength, lesser the velocity, more the refractive index.
Yes, sir. So
Let's say this is X, this is Y. X is the denser medium,
Medium and Y is the rarer.
rarer medium. How do you know that? Because wavelengths are directly proportional to velocity, inversely proportional to refractive index. So 3500 angstrom, whichever has the wavelength, that has the lesser velocity, that has the greater refractive index. Clear?
Yes, sir.
Yes. Okay.
Yes.
So now, what is the refractive index of this mu x? What is the refractive index of this?
Mu y.
Mu Y.
Understood? Okay. Now, when the ray of light is going from denser to rarer medium, then only what is possible? Total internal reflection will happen only then. Correct or not?
yes,
Yes.
sir.
Yes, sir.
So denser to medium means mu is going from x to y, which means what it will be? Mu y by mu x. Correct?
Yes, sir.
Yes. Now this will be equal to sin I by sin r. Correct?
Yes.
Yes, sir.
Sin of the critical angle of incidence divided by sin r. Sin r will be what?
1.
1.
1.
1.
So mu y by mu x will be nothing but lambda x by lambda y. Do you agree?
Yes, sir.
Because refractive index and lambda are
Inversely proportional.
exactly. Therefore, lambda is what? Lambda x is 3,500 angstrom, lambda y is 7,000 angstrom. So as Rahil said, you're getting sine IC equal to how many times?
1/2.
1 by 2. So sine IC is 1 by 2. Therefore, what is IC?
30.
30.
30 degrees. So same answer asked in a different way using wavelengths they have given. So far they were giving directly refractive index. Now this time they have given wavelength. Is it clear?
Yes, sir.
If you want to note down anything, you can note down. Once it's over, let me know, then we can go on.
Done, sir.
Done, sir.
Done, sir.
Done now? Okay, great. Now let's go on to the next question. Okay. If the critical angle for total internal reflection from medium to vacuum is 30 degrees, then what is the velocity of light in the medium? Okay. Now tell me, it is moving from the medium. It is moving from the medium to what? Vacuum. So that will be nothing but mu of vacuum divided by refractive index of the medium, correct?
Yes, sir.
Which will be nothing but
Nine eyes.
sin IC by sin 90, correct?
Yes, sir.
Now, refractive indexes are inversely proportional to what? Velocities.
Okay.
So mu vacuum by mu medium will be equal to velocity of the light in medium by velocity of light in vacuum. Are you understanding?
Yes, sir.
Yes, sir.
Yes. Now, what is the angle of incidence? Critical angle. What is critical angle?
30 degree.
30 degree.
30 is equal to velocity of light in the medium. I'll keep it as v. Okay. What is velocity of light in vacuum? Velocity of light in vacuum is
3 into 10 to the power 8.
3
yes,
into 10 to the power.
vacuum or even air is 3 into 10 power 8. So now, what is sine 30?
1/2.
Is equal to v divided by 3 into 10 power 8. So what is v equal to? 1 by 2 into 3 into 10 power 8. So what will be the answer?
1.5 into 10 to the power 8 meter per second.
Understood?
Yes, sir.
So that's the
Yes, sir.
second option. Are you clear with this now?
Yes, sir.
Yes,
Any
sir.
doubts?
Yes, sir.